Hi, everyone. So, I'm going to do a deep dive for my new device, Nirvana, into the space and material modes. So, if you haven't already, definitely watch the full walkthrough, or familiarize yourself with the device concept somehow, either with the walkthrough or with the user manual, because this is just going to be a deep dive into these two sections of the device. So I won't be explaining the larger context for those modes or the device itself. So hopefully you know what this device is about, etc. So if you know what the device is about, you'll know this is a feedback synth and that the space and material are two different feedback modes. The reason I'm combining them is because they're very similar, almost identical, but with some differences. So yeah. So the space and material mode both try to emulate or simulate 2D situations where you can add microphones and speakers to a space, a 2D space, and create feedbacks with them. Additionally, you can add sound sources to these spaces. These can be like samples or oscillators to affect the feedback, or you don't even have to use these modes for feedback at all. You can create a Leslie speaker in them, or use them for reverbs or resonances, or um, you can make crazy oscillators. Crazy synths with them by having all these oscillators flying around and stuff. So there's a lot more you can do with these modes than just feedback. But of course, the main point of the device is feedback, or the original purpose, I should say. Great. And hopefully, that you can play this instrument with MIDI notes or by turning on this drone mode and just pressing play. And that's what I'm going to do now because it'll be easier. I'm going to turn on drone mode so that it'll just be constantly playing so that I can just talk about it. So I'm not going to be using MIDI notes for right now. So yeah, in both the space and material modes, like I said, you can use these different objects in this 2D space. So the objects you can make are microphones, speakers, and sound sources. This cat here is the listener in the room. Hopefully, you know that. And so when you're creating all these sounds in the room, there's different places to listen to them, and this is like the where you are as a listener. And you can add these three objects. You can add up to four of them down here. So there's this little panel right here, and this is like the main settings of the space or material mode. And so here you can add more objects. So if I click this microphone, we added another microphone, and so on. Now this thing here is to duplicate. So if I was to have this mic and I wanted to duplicate it, I'll just click it so it's selected, and then I'll press this duplicate button. And now if I move it, we reveal that there's an identical microphone underneath. Let me just delete them for now. And great. Let's some other parameters here. There's not too many. So when we're in the space creating feedback, we want to also simulate what space we're in. So to do that, we use IR files, and those files you can select here. So changing this IR file will change the kind of reverberance of the space that we're in. And the options are like the standard convolution reverb options. It actually pulls from that pack. So you're probably quite familiar with these IR files if you've used that before. So you can just use your favorite convolution reverb IR files to change the kind of reverberance of the space you're in. Now, that now the IR files kind of, in a sense, simulate or whatever different spaces of different sizes. But separate from that is the actual area right here, parameter of the room. So even if I chose a small room here or a big room, it doesn't affect the area. And what do I mean by that? So basically, when we're feeding back mics and speakers, which I'll show you now, let's feed one back. So as you see, I'm moving the mic close to the speaker, and it feeds back when it's close enough. I can also just turn up the volume to do that. Similar to what happens in real life. Now, when you notice if I'm like this, there's no sound. So you have to get close enough, right? Now, what is close enough? Well, it all depends on how loud the mic is, how loud the speaker is, and how big the room is. Additionally from that, if I turn this up higher, let's see if this works. You can hear when I move the mic back and forth, there's pitch changes. And that's, if you know, from the Doppler effect, from moving the sound source closer and further away from the listener and all. So that Doppler effect and that kind of distance factor, it's all determined. It's also scaled, I should say, by this area. So that's all determined by how big the room is. And this area changes the size of the room. So if I made it really small, now it's going to feed back like a lot more. See, even if I'm far away, it still feeds back. Now, if I turn the area way up, nothing. I got to get pretty close now. Yeah, I had to get really close and probably crank it up or something. So just to reiterate all that I just said, changing the IR space doesn't change the actual size of the room. It just changes the reverberance. I didn't want to link those two together to give you more options. So the area and the size of type of room are separate parameters, just to clear that up. The feedback is not totally just the signal of the mic and the speaker feeding back. It also does incorporate the reverberance in that feedback. So changing the type of space can potentially also change the tone and quality and timbre of the feedback itself, depending on the room you're in and how big the reverberance is. And this parameter here, FB bleed, kind of it attenuates that. So this FB bleed attenuates the volume of the reverb feeding back into the microphone. So if this was all the way down, then none of the space's reverberance would make its way into the microphone and it won't affect the feedback. Probably can't tell it from this example, but if you had a very strong reverberance, that could happen. And if you turn this way up, then it will add more of the room's reverberance in the feedback or allow more of it. Now, I most of the time that's not a problem. For some reverbs, if this volume is too high, the reverberance will be so loud going to the mic that it will affect the feedback so much that it'll just be the same tone no matter how the microphone moves and all. So you don't want this too high. Internally, I've actually attenuated it a lot, so you might not even have that issue so much anymore, especially if you keep it here. But certain reverbs are really strong for really big rooms, like the warehouses and stuff. So for that, you might actually even turn this down, or you just figure it out. I almost never move it from where it's at now, but you can play around with it. Yeah, so just trying to explain. Let me paint you a bigger picture so you really understand how the signal flow works in this, since this is a deep dive. So basically how the feedbacks and sounds are considered in the space and material are through delay lines and signal attenuations, which means like just lowering the volume. And so basically, if we have our listener, right, and we have our microphone, and these are kind of like all microphones. Like our ears are both microphones. You could think of it, and so is the microphone is a microphone. So in underneath the hood, what's happening is we're just considering the distances of speakers, and sounds are the things that produce the sounds, and these are the things that hear the sounds. So underneath the hood, it's just considering the distances and the angles between these sound generators and these listeners, and microphones being a listener too. So if the microphone was angled this way and the speaker here, then the volume would be very low or inaudible because it's not facing the speaker. But if I faced it, it would become more audible. And then the other aspect of it is the delay line. So how far are these from each other? How big is the room? And that will be the delay from this sound going to this sound. And that could be important to know if you're going to design things where you really want to lower latency. Like let's say you wanted to make a speaker modeling effect, and this sound source is like external input if you're using this as an effect. And then you have, let's say, the sound source right next to the microphone, and then the speaker right next to the cat, so that this effect essentially just gives you the sound of the speaker and microphone models. In this situation that I just described, you'll want low latency because you know it's an effect. If you're playing guitar, you want it to be a very low latency from here to there. So when you're making something like that, it's good to understand the delays and all, because you might want to lower the area down and other things to reduce the delay time as much as you can. The other thing to consider in that, and this is kind of a lead up to that, is this pre-delay thing. So by default, a pre-delay is on and that pre-delay is for the convolution reverb, the reverb of the space. So I have a pre-delay line. The time of that pre-delay line is determined by the area. So if the area is smaller, the pre-delay time is smaller, and if the area is larger, the pre-delay time is larger. Like I said, if you have effects or situations where you want to remove as much delay as possible or things like that, or any other reason, you can turn off the pre-delay here. Yeah, so that's this whole section. Now, hopefully, maybe you noticed or not, when I click these different objects, the parameters in this window change. So these are the parameters of the selected object. And so let's start with the listener. So if I select the listener, there's only one listener. You can't add more. There's only one listener in the room. And just before I get into this, the listener has 2 ears. So you can almost imagine it like there's 2 microphones, maybe, that are angled like this. I don't know, something like that. This is kind of what under the hood the listener is like. Let me remove that one. It's got an ear or a microphone facing this way and an ear and microphone facing that way. And so when you angle it and stuff, it will change that. So let me do an example. I'll do a little feedback here. And now I'll rotate the cat around so you can hear. There. So that's kind of how the cat listens to the space. It's to kind of mimic how our ears work. It's not like, like super accurate or something. Anyway, so here are the parameters for the cat. Now, if you don't want that whole stereo space, I was just showing you can press mono and it'll just sum everything to one signal. Okay, ignore sources. So here, like I said, this type of object is an audio source. So right now it's just noise. If I turn it up, we can hear it better. The reason the re- the reason it's even here in the first place, really low, is because if you don't have any audio source in the room, then the feedback won't happen. It needs some kind of sound to get started. So this works as like a very low background noise, like pretty much imperceivable to instigate feedback. But you don't have to use it like that. You can use it like an oscillator. Okay, let's get back to what I was going to say. So ignore sources. Now, like I described before, both the microphone and the cat, they pick up sounds. So the microphone listens to this sound, and so does the cat. But what if you don't want the cat to hear this sound? Like, and why would you want that? So, for example, what if you wanted like sounds in the room, like it could be external audio or samples or something. But let's say you don't want to hear them in their raw form, but you do want to hear them in the feedback, or you do want to hear them going through the mic and out the speaker, but not just purely the sound going to the cat. That's what ignore sources is good for. So if I move this close to the cat, let me press ignore sources. So what's happening when I'm toggling is this: if when it's on, we no longer hear the source directly, and instead we're just hearing the source going through the mic and out the speaker. Let's hear it again. So right now, ignore sources is off. And now ignore sources is on. Okay, hopefully that made sense. So this is pretty useful in different scenarios, like the one I was describing before. Even if you wanted to have like an effect of just the sound of the microphone and speaker model, then you don't want to hear the source outside of that. So for that situation, you'll want to ignore sources. Or for any other reason, you don't want to hear the sources, or you just want the source to be part of the feedback, you'll turn on ignore sources. Okay, I'll turn it off for now. Meow. If you press meow, it meows. I mean, this is just a cute thing. But, you can also use it to like hear the sound of your space or stuff like that. That just sends in a meow basically to all the mics and to the reverb. It might send it to the listener too. Can't remember. Okay, reverb. So, as you can hear, there's reverb in the room. Let me turn it up. So yeah, you can hear the reverb. If you don't want the listener to hear the reverb, this is the volume for it. So let's hear it again with no reverb. So there's no reverb now to the listener. There is still reverb in the room that the mic picks up and goes through the feedback, but there's no reverberance that's sent directly to the listener. So there's no like obvious reverb tail. But you could possibly still hear the reverb within the feedback, especially depending on the kind of room you have. And here's the gain for the listener itself. Pretty self-explanatory. Now, all these objects have positional, and most of them have rotational parameters too. And those parameters are here. So you have the X and Y and rotation. Now, as you've been seeing me do it, you can also just click and drag to change the X and Y. And if you hold Command or Control and click and drag, you can change the rotation on the interface too. So yeah, that's the listener and its parameters. Let's check out some other ones. So let's go to the microphone. Or let's go to the speaker, actually. So here's the speaker. Now, speakers and microphones also have IR files that you can use, and you can change their types here. So, if I want, let's hear how this speaker sounds with feedback. Okay, let's hear this speaker. Okay, let's hear this speaker. Now, they're all kind of similar because this type of microphone model also has a very strong effect on the sound. Let's see if I do a horn tweeter or a small speaker. This will probably sound quite different, maybe. Yeah, so this small speaker model is pretty squeaky. Yeah, so as you can tell, if I change the speaker model, the feedback changes. And that's because the microphone and speaker models, they add like a filtering. And so that changes the sound of the feedback. If I turned it to none, right now we have no speaker model. And let me do the same for the microphone. I'm going to turn it to none. So right now, there's no microphone and no speaker model, which means there's no filtering happening. And the source of this feedback is oh, it's not there anymore. Let's change it back. Is this white noise. So we have a very quiet white noise, and then we have a mic and speaker with no model, no filtering. So let's hear how the feedback sounds like that. Pretty crazy. Doesn't sound like the feedback we're familiar with anymore. And that's because there's no filtering. It's all just like digital noise in this delay line feedback. So it's just noise now in the feedback and no like specific tones and stuff like that. So generally you'll want a microphone or speaker model, although you can explore that too, or you can add a filter to the mic, as we'll see later. Okay, the other parameters are, of course, we know about rotation and X and Y, so no need to describe it. Now this clipper here, which after making, I feel like it's not the most useful thing. But basically, this isn't the clipping for the actual speaker. Mics and speakers and all I have them all as hard clipping to kind of like try to emulate just like speakers being blown out if they're too loud or something. Not very accurately, of course. But this clipper actually deals with the speaker's input. So multiple microphones can actually be sent to one speaker. And those can easily, of course, clip the value. They can be too large. So this is the input clipper. And so right now it's at hard by default, but you can have a soft clip input. So if you send a lot of signals to one speaker, you can soft clip it or hard clip it. But yeah, I found it not to be. It can make a little difference, but it's maybe not the most effective parameter. But play around with it. At certain situations it could be desirable. And then there's the gain of the speaker. So of course the microphone and speaker gains also control things about the feedback. It's not just the distance and the angles, but it's also the gains. And those will also affect the quality of the feedback too, if it's going to be like a really clippy feedback or not, and stuff like that. Great. So that's the speaker. Now let's go to the mic. So as we saw, the microphone also has a model. So if I change the microphone model, should change the sound. Yep. And that's because, like I said, all the microphones have different filterings or impulse responses. Okay. And of course, it also has X, Y, and rotation. Now it has this here, the two speaker. So if I had more than one speaker, okay, let me turn it up. So right now it's just sending to speaker A. Hopefully you notice when I toggle A off and on, it stops the feedback with A. Now let's send it to speaker B. Let me make them closer. Cool. So here's A. Here's B. I guess this is a pretty squeaky mic. Let me try a different mic. I don't know. This one? I mean, I'm just finding one I feel like, but they're all fine. Okay. So yeah, you can hear A and B sound kind of different. Now I can also send it to both. And of course, sending it to both will mix all the feedback because the signal's coming out of both speakers and feeding back into it, yada, yada. So yeah, let me delete the speaker. Oh yeah, I didn't say in the top left corner of these ones, there's a X mark to remove those objects. Okay, and then let me turn this down. Okay, and then the final thing the microphone has is different effects you can choose from. Only 3. So there's a filter, a resonator, and a string model, which is a car plus strong. So the filter, very straightforward. We can use the filter to change the feedback further. So let's lower the low pass and see what happens. I'll turn up the resonance. And let's change the filter type, maybe a high pass. Yeah, so filtering does a lot to change the tone of the feedback. So it's a good one to modulate and use. And then, okay, so now let's hear the other one, the resonator. This one will probably make a tone. So yeah, let me turn it down. Yeah, so the things like resonator and string, they're pretty strong feedbackers because of how they encourage the feedback. So let me turn it up. And so this is a very just like simple resonant bandpass resonator. And the exciter for it is obviously whatever signal's coming into the microphone. So like I could instead even send noise. Yeah, let's send just some noise through it so we can hear it a little more clearly. Oops. Sorry, I turned up the speaker by accident. Okay, so here's the resonator. Let's ignore the sources. Cool. Now I'll change the tuning of the resonator. Let me make it higher. And you can change the bandwidth, which is like the decay. And yeah, the bandwidth's really low right now, so it's kind of noisy. Yeah, so, and then now let's do here the same for the string model. And let me turn down the dampening so it's brighter. And I'll mess with it here. And the decay time. Yeah. So, and this is all going through also the filter here. So if I turn that off. Well, and then of course it goes through the speaker filter too. So you hear that really filtered kind of sound to it. Okay, so And then as feedback directly. So right now I'm just feeding back the signal, but with this string kind of model. And let's change the dampen. Okay, so the string and resonator models are good just for affecting the feedback in different ways. And so you could make, a very tonal kind of feedback system with them. You could also just set them up in a way to make this mode into different resonator and string models altogether by adding envelopes to the noise and stuff like that. Or even just, envelopes to moving the noise around to trigger it. So you can use it. It's pretty open-ended how you want to use them. Now, the string and resonator tunings, this tuning transposition, it follows the keyboard. So if right now I have drone mode on, but hopefully you can also play this device with your keyboard, with your MIDI notes. And when you do it like that, these notes are transposed with your keyboard. So you can actually use the resonator and strings to do tonal kind of feedbacks using your MIDI keyboard as a polyphonic synth. And you can also do that with the filter. So here's a very deep divey thing, but also should be well known. So I want to make it kind of apparent. Make sure I got good speakers. So let me turn this up. So as you know, we can change the fundamental of the feedback by filtering different frequencies. And basically, if I turn off drone mode, you can see there's an option for MIDI 2, and hopefully you know this, to apply the MIDI to the filters. And what that means is it applies the MIDI notes to the filter cutoffs. So that means if you play higher MIDI notes, the filter cutoff frequencies get higher. And if you play lower MIDI notes, they get lower. And if you press middle C, then it'll play the filters at the cutoff frequency they're set at. So, if I were here at 544 hertz, if I press middle C, it will do the same filtering. And that's me pressing middle C right now. And then if I went up, now I'm an octave higher, I believe. Yeah. So yeah, I'm just on my keyboard right now playing a middle C and then a 1C higher. A 1C octave higher. Now, if you want those frequencies, now see, I just kind of played a chord. And because this is a polyphonic synth and the filter MIDI notes affected the filter cutoff for each voice, you can play chords. Now, if you want this to be the same, like middle C to be the same frequency as a middle C on an oscillator, here's a little trick that's not so obvious. Click the cutoff and type 0.5 and press enter. And that will take you to the middle value between 0 and 1. And that middle value is 624 hertz. 624 hertz is the middle C frequency, I believe. So if you change this to 624 hertz, or any in this device, any filter cutoff to 624 hertz, or press 0.5, enter, that will also bring you to 624 hertz. Then it's set to middle C, and then you can play like a keyboard, and it will match other synths. Now, that's not 100% true. You might have to move this slightly back and forth to fine-tune it. So just maybe have a reference synth to tune it with by moving it slightly back and forth. Other things that might affect that tuning are, the microphone and speaker model and distance. So yeah, like I said, just back and forth to find it. If you're going to do this, I recommend using a resonant bandpass filter, but you can also get away with a low pass and other things, just make sure you turn the resonance up enough so that the fundamental of this filtered frequency takes over. You'll notice certain situations will do it better than others, or it might fall apart at different octaves depending on the microphone and speaker and the feedback situation. But if you're just doing something simple like this, it should work pretty okay. Anyway, so those are, some deep divey, or, I explained this in the walkthrough too, but that's a really useful thing to know to make this a tonal, diatonic or whatever harmonic, polyphonic synth, to use this filters thing. All right, I'm going to go back to drone mode. And yeah, that's the microphone parameters. I'm going to turn the effect off. And the final one is the source, which is pretty straightforward. So source has an X and Y and a volume. And then this is to choose the type of source it is. So let's stop ignoring sources and turn this up. So as we can hear, this is just a white noise oscillator. Then we have some classic basic oscillators with a transposition. Now, if this was in MIDI node polyphonic synth, changing, and not just the oscillators, but anything that has a transposition or tuning like this, if you press MIDI notes, it will follow the note you play. So if I turned it back to turn off drone mode and play some notes, I'm just playing my keyboard and it's retuning this. You can also transpose that here. Okay, back to drone mode. Okay, the other thing we have is a sampler. So I'll drop in a sample. So yeah, you can do sample playback and change the tone of that too. You can click and drag to select the region to loop. And just like the oscillator, if I turn off drone mode, this will repitch it with MIDI notes. Let me turn back on drone mode, and you can reverse it. Really basic sampler. I wasn't trying to give you a state-of-the-art sampler here, just something to throw in the space as another sound source to use in many different ways. Below that is external in. So if you're using Nirvana audio effect, this is external in is the sound coming into the audio effect. If you're using Nirvana the instrument, then on the unpopped out window, there's some drop down menus to route in audio from any other track, external input. And whatever you routed there, that's what comes in through here, external in. And then this last one, other system, this is the sound from the other system. So yeah, this is a system, this pink, and here blue, here's another system. So it's like having an A/B voice in a polysynth or whatever. So if you press other synth system and you had another system active, then the sound from that system is what you get when you select this. So let's set that up just to demonstrate it. I'm going to turn this off. I'm going to turn on this other system. Make it kind of noticeable. Okay. So I turn the volume here down. This is the main volume. It doesn't affect the output we're looking for. This is the output, the main output. So I turn that down. We can no longer hear the blue system, but it is making this screeching sound. Okay. Now let's go back to the pink. I'm going to turn it on. Okay, we hear the noise. Let's go to the other system. And hopefully you can tell now this object is sending the same screechy tone we hear in the blue system out of it because it is the audio from the other system. I'll turn it back up. Yeah, and when I turned it off, it just went to a buzz, I guess, because there's nothing. Um, Cool. And so that's pretty useful. For instance, you could design a circuit or a material in one system and then have it like fly through the space of the other system. Or you could cross feed them back. You can also cross feedback with this parameter here, but doing it like this gives you like more specific kind of control for how you want to cross feedback the system. So there's a lot you can do with that. A lot even I haven't explored with that. You can do insane, crazy, complex feedbacks between the systems with things like that. So pretty cool stuff, I think. So that's all the parameters for all the objects in space mode. And hopefully you get an idea of what space mode does. I'll dive into a little more stuff, but first I want to just address all those parallels in material mode because it's basically identical. So this should go kind of quick. So let's go to material mode and let me toggle back and forth so you can see they look kind of the same, but a few things are changing. All right, now let's talk about what's changing. So all the microphones turned into these little circular things and all the speakers turned into these whatever the hell these things are. So what the hell is going on? And what is material mode different? So material mode, like space mode, is about creating feedback between mics and speakers and having sound sources. But there are some key differences. For one thing, if we look into the main parameter section of this materials, instead of it being different spaces to choose from, we can choose different types of materials. So we have metals, plastics, woods, we have different types of them. So there's no space reverb in this mode. Instead, there's the resonance of these materials we choose. And then the other aspect is that these are still mics and speakers, but they're supposed to be different types. So this is supposed to be a piezo mic, like a contact microphone, and this is supposed to be and this is supposed to be a surface transducer. So this is a type of speaker that doesn't have a cone, and I'm talking in real life, and that you put on a surface and it vibrates the surface so that the surface itself can emit the sound or for whatever other purposes you need to do that. So this is kind of like a surface vibration speaker. So both the contact mic and surface vibration speaker deal with sound on a surface instead of through the air. And if you've done this in real life, it creates a different type of feedback through the surface waves. And so it's very similar to space mode, except that instead of creating feedback through the air in a room, we're trying to create feedback on a type of a material. And so, like I said, you can choose the material. I made these material IRs myself. So they were made with contact mics and stuff. So actually, these materials already have the sound of the contact mic and stuff through them. So I say that because you're welcome, of course, to keep using the microphone and speaker models in this mode to filter the sound differently depending on them. And you should definitely try that out. But another thing you can do in this mode that you can't in the other in the same way is if you choose none for microphone and speaker, it won't create that kind of noisy feedback we heard in space mode. Instead, it creates a feedback way more true to the actual sound of the material. Sorry, that's a park bench is a really long one. Oops, turned it a little too far down. Yeah, so I encourage or recommend in material mode to try first to turn the microphone and speaker models off to none, and that way you can hear the sound of the material better. Now, if you wanted to just hear different filterings, yeah, do it. Do whatever you want. See, let's hear it with this model. So it will sound different. with the filterings of the mics, but I encourage you to first hear it without it and then decide what you want to do. All up to you. So yeah. So some differences in the mode, again, is you can choose, instead of spaces, you can choose different types of material. Let's try some wood. I don't know what's a good one to demonstrate. That one's like a really whiny one. Yeah, a lot of these small wood things are kind of whiny. This one's probably not. And a lot of these are kind of experimental. Like this is car traffic bridge, so it's like the traffic bridge. So, a lot of these aren't like, vowels and stuff. They're not or fire. They're not actual materials in other. So, yeah. The other big differences in this mode are kind of more under the hood. It actually just kind of processes the feedback differently. In this mode, the mics will go through the materials, and actually the IR files for materials are 4 different ones per object, which are placed in the corners here. So actually, if you move between the corners, it's actually different qualities of the material that you're hearing. So for example, with this one, this is a metal plate. And for this, I recorded different points on the metal plate, the IR file, and then I just put those points in the 4 corners. So that's quite different. Space mode doesn't do anything like that. It only works with 1 IR file. These work with 4 that are interpolated depending where the microphone is at. Another underneath difference in this, there's several. Like one is that the area is scaled differently. The area gets much bigger for the spaces than the materials, because of usually materials are not as big as rooms, though they can be. And another aspect that's different is that these don't have rotations in the same way. So if you'll notice, the microphone and speaker don't have rotation, they have tilt. So angles and rotations aren't considered really as strongly in material mode like they are in space mode, and that's because the way the sound emanates is different. It's less directional in a lot of these situations. Now, this isn't trying to be, neither of these modes are trying to be like super accurate modelings of being in a space or on a material, but just to kind of give you a feeling of it. So in material mode, angles aren't really considered in the same way as in space mode, and therefore the stereo space isn't as strong and prominent in material mode as space mode, and that's just kind of deals with how the sound kind of emanates on throughout the material in every direction. Now, what is tilt then? Tilt is like I'm trying to kind of, through complex filtering and stuff, I'm trying to kind of emulate the sound that you get is when you're tilting a microphone or a surface transducer on a material. So if you did that in real life, if you did a surface feedback in real life and tilted the microphone or speaker, it will change the tone. And it's kind of works like a high pass filtering almost, but a little different. It's a little more complicated, and deals with the coupling of these. So I'm going to create some feedback, and then I'm going to tilt it, and hopefully you'll hear the sound of the tilting. Let me try a different sound. So hopefully you could hear that. I mean, you probably could. And it kind of has the similar or same effect as using a high pass filter, say on the microphone. But it is a little more complex and different, especially if you try out different materials. It kind of more shifts. What I'm doing underneath is I'm like, it's actually way more complicated. I'm like detecting the modal peaks of the material IR, and then you essentially shift those up through FFT filtering of sorts, and depending on the tilt amount. And so this is a cool thing to modulate and get like some pretty wild sounds out of. You can also tilt both the mic and speaker. Keep in mind you might get some gain loss from doing that, so you might have to boost the gains higher if you're doing tilting. It just all depends. So that's another difference between space and material mode. Oh, one thing I forgot to mention about all these modes is that for all these IRs, for a speaker or a space or a material, you can drag and drop your own. Just get an IR file or an audio file if you want, but I might process it a bit internally. And you just drag it and drop it on the menu, and it'll load your user IR files. So just drag and drop to do your own sounds. Like, for instance, I can add I don't have any to show you on hand. I could drop in a random audio file, but it'd probably sound weird. Okay. Okay. So that's almost all the functionality of these. The only one thing I haven't functionality-wise I haven't talked about is this button here. Clear feedback on new voice. So if you are playing this instrument with MIDI notes, let's say I was in this mode. So let me make some. Oops. Let me add a model. Okay. So if I played a note and I played another note, hopefully you can hear the notes kind of sounded, they went from silence to feedback at the beginning. Now, if I turn this off, and that's what this does. This clears the feedback between the voices. If I turn this off, after some voices, you'll hear it actually just doesn't have that ramp up and just bleeds from the last voice. So hopefully you can tell every time I'm hitting a note, it just starts with that feedback. If I turn this on again, it's got that kind of ramp up. So this clears, if this is on, it clears the feedback from the last voice so it doesn't bleed into the new voice. And this is usually pretty useful. Like if you're doing different notes and all sorts of stuff like that, you don't want to have the sound of the note from the last voice in the new one. Now, sometimes you might not care or might even want that kind of bleeding to happen, so you'll turn it off. The other reason is if it's on, one thing, it takes slightly more CPU at the beginning of the voice, which shouldn't be a big deal, but you might have a bump at the beginning of the voice with this on because it's clearing all the convolution, etc. And the other reason is there is a slight more latency when this is on. So if this is on, there's a slight more latency to wait for those to clear and bring up the volume so there's no clicks. So this will introduce slight amount of latency and clear the feedback. So you might not want that in some situations, so I give you this option. So that's all the functionalities and everything about these modes. Now, there is one more I wanted to talk about. Sorry, and this is talked about elsewhere. Now, hopefully you understand the modulation system. I'm not going to explain it in this video. You can modulate all these parameters with these little circles around them. And these are ways you could modulate filter parameters, volumes, but also positional things. Now, there's another way. Now, down here at the very bottom, there's another way to kind of move around objects. And that's this object position automation looper. So this is like an automation looper where you can record automations of the movements of objects. So object position. So all these objects here that can move around or here, this allows you to loop those movements. So I don't want to go over it too in depth because I do that elsewhere, but it's good to know for this mode. So if I pressed record, I can move this around. And now I'm not doing anything, and you'll notice there's like a little ghost mic flying around that just, so this is my recorded movement. that I just did of the mic position. And here it says length, so it's looping that movement every 2 bars. If I lowered it to 1, now it just does the first bar of my movement. Or I could do it the first half bar. And yeah, I'm not gonna do a whole tutorial about this, but this is another way to automate the movements of your mics and speakers and rotations. You can also record the rotations of them. So if you want more complex kind of movements internally that aren't just oscillators and envelopes, LFOs, I should say, you can use this looper at the bottom. And this is re-triggered on every new voice. So it works as almost a complex envelope of sorts per voice. Okay, so that's all the functionality. So now I just wanted to talk about just a little bit about, working with these modes. And this is a little loose, so I apologize for it being a little meandering. So, for people who know feedback well and stuff, this might just be obvious stuff. So maybe this is just to kind of help you if you don't know much about feedback and stuff like that. So, I just want to talk about how to work with feedbacks and things you can do with it. So, one thing you can know is that all the sounds in this room affect each other. So, you can do a pure feedback here with just mic A into speaker A, but we can also introduce another mic. So this mic has a different filtering and is also sent to speaker A. And if we introduce it, it affected the whole feedback. It's also a lot louder than mic B was also a lot louder than mic A, so it kind of took over the fundamental of the sound. Now I can put them at more similar volumes. And now that they're at more similar volumes, you can find points that kind of incorporate both tones of them, or, ways of messing with that. Now, if I added another speaker, that will also change things up. So here's another speaker with a different filtering. And if I sent B to that, now B is going to both A and B. B mic is going to A and B, so it's going to affect the feedback of also A and A, and they're all affecting together to create a whole different tone. However, if I stop sending B to A, then we're going to have two independent different feedback tones, the B to B tone and the A to A tone. Sorry, so let's hear what those two tones are like. And if I move them all closer together, they will all bleed again. Yeah, and if you had these things moving around through modulation or through automation, etc., then these tones will shift over time, as you can imagine. And of course, you can also recreate famous sound art things like mics swinging back and forth. So for example, hopefully you understand the modulation system, and then you can click this X button here, which is the X position, and kind of modulate it. Let me get it. Must be a little quiet or something. Yeah, so now we have a moving mic that creates periodic tones when it passes the speaker. And I could do the identical thing for this other mic. Yeah, so, you can create these dynamic movements. You can create feedbacks that all feed into each other and shift over time. And like I said, we can do non-feedbacky stuff. So if I turned this oscillator up again, so we can hear it's a saw wave, but watch when I move it around. So we get some kind of pitch shifting, we get some kind of phasiness happening. And so if I automated that movement and turned it up, we can use this situation to create different pitch and phasing effects. I could even duplicate that oscillator, move it. Okay, and now we have two, and I could change how the other one's movements are. Sorry, turn that off. Okay. Yeah, so you can have different oscillators modulating different tones, of course. Oops. And you can even be rotating the listener itself to get different kind of phasing and volume adjustments. And I could make these less periodic oscillations by using purlin noise. Yeah, so now you can have some kind of complex phases happening. Or instead of listening to those oscillators directly, I can ignore the sources and just have... We can still kind of hear the sources even without the mics because we're hearing the reverb of the sources in the room. But yeah, so now let me remove that speaker. And now if I move this mic, the speaker A is now close to the listener. And now let's move the mic to the sound so we hear them through the speaker. And I can change the mic model so we hear them different. And yeah, we could even have another speaker with a different modeling and a whole different mic sound. So yeah, just showing you can make this not a feedback device at all. And I could turn off drone mode and play these with my notes. Let's turn up the release time. So yeah, you can just use this as a polysynth in all kinds of different ways. And same within material mode. I'm not sure how this will sound in material mode. Let's see. All right, pretty crazy. Anyway, so covered a lot of ground. Now you should understand better what's going on under the hood and how these two modes work, and a little bit of different use cases for them. But really, the sky's the limit with this device, especially when you consider the circuit mode and how you can use all these together with different cross feedbacks. Lots that you can do. Hopefully that was helpful. Thanks for watching, and this will work.